Hello everyone. So this session will be on shifting into an effective semantic model in Azure Analysis Services. So let's get started. For those who don't know me, I'm Thimantha Vidanagamage. I love working with technologies such as Microsoft Data Platform technologies such as Microsoft Power BI, Azure Analysis Services, and Azure Data Factory. The most important thing out of all the details that you see in the screen now is my Twitter handle at Thimantha. So please connect with me on Twitter as well. Looking at the agenda for today, firstly, I will take you through some basics of semantic models. Later on, we look at why some semantic models are ineffective and what makes some semantic models effective. Finally, I will be wrapping up this session by shifting an existing semantic model into an effective semantic model. Looking at the semantic model basics. So a semantic model is usually a data model that's used for analytical purposes. It's specifically catering the end users. The end users at this stage are the business users in a particular organization or particular company. So what they do is they perform data-driven decision making with the semantic model. There are two types of semantic models. Those are tabular semantic models and multidimensional semantic models. Previously, it was only multidimensional semantic models, but later on, tabular semantic models came up. The tabular semantic models are a lot more simpler compared to multidimensional semantic models. And the tabular semantic models are a lot more compressed and well optimized compared to multidimensional semantic models. In this session, we'll be focusing specifically on tabular semantic models because Azure Analysis Services only support tabular semantic models. Looking at the basic concept of a semantic model, it's a really simple concept between a fact and a dimension. A fact is basically a table. Is a table with numerical figures, and a dimension is basically an aspect of looking at the fact. So, for example, a fact can be sales and the dimension can be region. So we can look at regional sales based on the combination of facts and dimensions in a semantic model. When it comes to the model design, there are two key model designs that are implemented when it comes to semantic models. It could be a star schema or it could be a snowflake schema. A star schema is a simple model design where to give you a basic understanding of that, it's basically a fact table in the middle, and there are dimensions surrounding the fact table that are directly connected to the fact table. And there is also snowflake schema, which is a bit complicated compared to star schema. It's where the dimensions have connections to relationships to other dimensions as well. So there is a bit of complexity in that. So when it comes to an ineffective semantic model, so I hope everyone had watched Pokemon. It was one of my favorite cartoons ever since I was a kid. In Pokemon, you have a character called Pikachu, who is the main character. That's the character in which each and every episode of Pokemon is based upon. So just think of an episode in Pokemon without Pikachu. What would it look like? It would not be persuasive for the audience. It would look really dull on the audience. So that's how, and the semantic model would look for end users if it's not effective enough. So why are some semantic models ineffective? The key point in here is that we as developers, there are situations that we misunderstand the end users, the viewpoint of the end users. We cannot expect end users to be familiar on how we look at things. So, something that might look really simple on us might be really simple for us, might not be the same for the end user. A very basic example is the camel case naming convention, the naming format. So as developers, we usually use the camel case naming convention in our development purposes, even in the semantic model. Sorry, even in the data warehousing part of things. But we can't expect that to be really comforting for the end users, because the end users are not technical users. They are not used to understanding. They are not used to this camel case naming formats and all that. So we should make sure that it's much more comforting to them. We should leave spaces between words when we are naming tables and naming columns, and we should make it look much more user friendly for the end user. And looking at the second point, it would be underestimating the value. It's underestimating the value of a semantic model. Think of a data analytics solution. We as developers usually spend a lot of time, do a lot of hard work in data integration and the data engineering tasks. And finally, when it comes to semantic model, there can be situations that we might not be paying the necessary attention as we did for the data engineering part of things. So in here, what we need to keep in mind is that the data engineering part of things is not really exposed for the end user. It's for development purposes only. But the semantic model is exposed for the end user. So it has the ability to even conclude a particular solution or project if the semantic model is not effective enough. So what makes a semantic model effective? The first point I would like to raise here is usability. Usability is where the semantic model is easy for the user to use. It's comforting for the user to engage in the analytics. Then the second point would be performance. The semantic model should be optimized and it should do a good job when it comes to performance, and which will be efficient and effective enough for the end user. And the third point is security. There should be appropriate security measures in the semantic model so that there will be no data breaches from the semantic model to the outside world. So I understand this to be a triangular concept. So just think, there is a semantic model that's really doing a great job when it comes to usability. It's really easy for the users to use. But when it comes to performance and security, it's not really doing a great job. Let's think of another semantic model that's doing a great job when it comes to performance, but not really up to the mark when it comes to usability and security. Still, it's not an effective model. Then let's think of another semantic model that has all really good security measures and not doing a great job when it comes to usability and performance. Still, it's not an effective semantic model. So all these three scenarios are not effective semantic models. An effective semantic model is where there is a appropriate balance between usability, performance, and security implemented. So let's look into the demo part of things. The demo will be entirely based upon the three aspects that I mentioned earlier: usability, performance, and security. So I'll just show you around the demo. So this is the developer point of view. This is how developer will use a semantic model to do the necessary changes and to basically improve the effectiveness and to do the necessary development. And this is accessed by Visual Studio. So we have access to semantic model here with the user Visual Studio, and this would be how the end user will see the semantic model. So in here, you will see the same facts and dimensions that were in the developers bit, but here it's accessed by Power BI. That's how the end users will access the semantic model to perform their analytics. So I should mention that when it comes to effectiveness, there are really basic tasks that should be performed. So like renaming columns, like renaming tables and hiding unwanted columns. So such stuff I'll not be able to demo in this session because of the limited time duration I have. But those are really basic and necessary stuff that should be should that should be done in order to build an effective semantic model. And this entire demo is based upon AdventureWorks. I had just brought in few fact table, AdventureWorks DW 2017. I had just brought in few fact tables and dimensions into the semantic model for you to demonstrate to you how this should be done, how we can improve the effectiveness of a semantic model. So let's move into demo one. Demo one will be measure groups and attribute groups. Measure groups are used. Measure groups and attribute groups are used to organize measures or organize attributes in a dimension. So just think of a semantic model. There is a particular fact table with like around 20-30 measures, and it's not really organized, and it's not easy for the end user to use the appropriate measures for their analytics. It's not easy for the end user to navigate the particular measures. Same with the attributes. Just think of a dimension. There are several attributes in that dimension, and it's not really easy for the user to navigate to the right attribute that they want to use for their analytics in that particular dimension. So in order to create ease in that navigation process, what you can do is you can create measure groups or attribute groups. These are basically to give you a basic understanding. This is where you create separate folders in dimensions and fact tables, and you put in you organize your measures or attributes in those folders so that it can be easily accessed by the end user. So let's move into the demo real quick. I have my customer dimension here. So let's look at the dimension point of view first. So I have the custom dimension here, and I just to show you a brief example, I have phone, which is the phone number, and email address here. So I would like to group this together and organize these two attributes as into one folder as content, so that if the end user wants to do some kind of analytics with that, he or she can easily drop into the contacts folder and do their specific analytics. So let's do that. Click on the email address column, and just go into the display folder property that's in the properties pane located at the bottom right hand side of the screen, and just enter the folder name that you need to display for the end user. So we have done that now, and we'll do the same for the phone number as well. Just go in here and just mention the folder name that needs to be displayed for the end user to perform the analytics. So that is done. Let's look at how it looks like for the end user. by just running a quick refresh. Okay, so here uh, you can see that there is a separate folder called contact, and inside that folder there are the two attributes that we grouped, uh, email address and phone. So let's do the same for the measures as well. Let's go into the internet sales track, and I would like to go into uh, sorry about this. I think I'll have to close Visual Studio and open it back. Just give me a few minutes, please.
We cannot hear you if you are.
Yeah. Sorry, I just had a issue with my demo, and now it's all right. Okay, so let's take reseller sales as an example. So when it comes to reseller sales, I'll group this reseller sales column under a separate folder just to show you how we can group measures into separate folders. But in this case, I would just group that as sales for the moment. And if you go in here, if you go to the end user point of view, you should be able to see under reseller sales, there is a separate folder called sales, and you can see the measure reseller sales inside there. So in this case, it's not really effective. The effectiveness comes into play when there are several measures in the particular fact table, and you can group those measures under separate folders, under separate measure groups as per the requirement. So that's about it for measure groups and attribute groups. And after, next, let's move into perspectives. So perspectives are often misunderstood as security measure. So perspective is not a security measure. A perspective is where you isolate a set of tables that are related to a specific domain into a, into one particular. You basically isolate the related table. You isolate the tables that are related to a specific domain. So in this, it's not a security measure. Anyone who has access to the entire model will have access to all the perspectives. Perspectives are usually there to increase the usability. So just think of there are a set of end users who are who who are interested only about the reseller sales part of things when it comes to the data model. So what we'll do is we'll just isolate only the reseller sales table and the related dimensions to it, so that the end user who is interested about reseller sales can only access those particular fact table and the dimensions and do their analytics in that. So let's move into that and see how it works. So I had already created a perspective for reseller sales. So if I just go in here and show you how it's like, you can see that I had only selected it here. For the reseller sales perspective, I had only selected the dimensions and fact tables that are related to reseller sales. So I have the reseller sales fact table here and the reseller dimension, product dimension, geography dimension, and so on. So only the related fact tables and dimensions are placed there. So creating a new perspective is easy. It's just a matter of just creating a new, clicking on the new perspective button, and you can just provide an appropriate perspective here, and you can select the columns that you need to show there. So that's about it. About perspectives, and I'll show you how perspectives will look like, for the end user by moving into the Power BI file. I will just go in here, transform data, data source settings, and I will just reconnect to my model. So when it comes to, you can see that we have our reseller sales perspective here, and we also have a perspective called model. So model is a default perspective that's available that consists of all the tables and dimensions that are in the particular dimension, a particular semantic model. So reseller sales is the restricted or the isolated domain with the related fact table and the related dimensions to the reseller sales. So if we just go and access that and see how it looks like, I clicked on reseller sales and I clicked on OK. So you will see that the number of fact tables, you can't see the internet sales fact table in here anymore. So you can only see reseller sales and the related dimensions to that fact table that are required for the end user. So that's basically it. And if you want to move back into the full model, so just kind of reconnect to the model again and click on model. There you go. So you have the full data model now in Microsoft Power BI, and you have access to the perspective that has a default perspective called model, which has the entire data model in it. So moving into the next demo. The next demo will be about Power Query optimization. So when it comes to Power Query optimization, there can be numerous number of ways and number of ways to optimize your Power Query. So in this demo, I'll be showing you a technique called technique for reducing the reducing the number of steps in Power Query, so that it improves your computation power and improves the performance in the model. So I'll just drop into a basic example. So I'll move into my Visual Studio, the developer view of the semantic model, and I'll go into internet sales. So in in internet cells, I would need to access the Power Query of internet cells. So I would go into the tables folder in DataGrillen Model Explorer, and I would click on the table, and I would go to table properties. And in table properties, I would go to design. I'm not sure how this would. Yeah, so I would have to re-enter the credentials. Um, this happened because I reopened my semantic model. Uh, just because of, so I think I'm not really sure why that happens, but at times certain measures just prompt out errors. I think it's a connectivity related issue. So as you saw there, so I had connected back to my semantic model now, to the Power Query view that I told you about. The internet says, so in here, you can see that in the right hand side of your screen, you have the applied steps. In the applied steps, you can see that there are some repeating, I would say repeating steps, repeating Power Query steps. So that's not really a good thing. So you should make sure to reduce the number of Power Query steps much as possible to improve the effectiveness and efficiency and optimization in the model. So I'll just go through what had happened here, and you will understand how this should be done. So firstly, what I did was I just imported the internet sales struct table, and after that, yeah, so I had imported the table. Then I understood the columns that are not important to me, so I just took them off straight away. Then later on, like after some time, I realized that there is a key called currency key. So currency key is directing to a dimension with multiple currencies. But in this scenario, I will only need to show, I would only like to show USD figures. So USD figures are only have the currency key of 100. So what I did was I just filtered out the currency key 100. Then after filtering out the currency key 100, this column is not necessary to me because I will not be doing any analytics with that. I had only filtered the US dollar figures. So what I did was I removed them. So that's what happened. So what would be a much more effective way to do this? So that could be, you go into this view, you just import the table, and firstly what you do is you just filter out the currency key 100 because you only need to see the USD figures. After that, what you do is you just remove the USD currency key 100. So even though it says the new step is inserted, but that's not what it happens because it's the same thing, remove column, so it will adapt to the same Power Query. As you can see here, for the same Power Query, currency key will be added up. So it would not be created in a separate step. And then after that, you don't need the rest of the steps here. You don't need filtered rows, and you don't need removed columns, and you don't need all that. And you can just group the rows, and yeah, that's really so this is really a basic example, a really basic scenario of how you can improve the effectiveness of Power Query. So you can be creative in your own way when it comes to reducing the number of steps and making your Power Query much more optimized and effective enough for the effective use. So that's about it when it comes to Power Query optimization. So after Power Query optimization, we'll be looking at role-playing dimensions. So role-playing dimensions is basically a dimension that's used for multiple purposes. Just think of a fact table that has two keys. Specifically, just think of a fact table called sales and a dimension table two-dimension tables called ship date and also order date. So those two are connected to as two dimension tables, two calendar tables. Those two are connected with two relationships to the fact table. So that can be brought down into a single table. So I have a scenario like that in my existing semantic model. I would take you to that step. So in here, we have the ship date key, ship calendar, and the order calendar, which are basically the same tables I had brought in twice to just connect it to two specific keys. That's ship date key and order date key. So what can I do here? I can have just a single table, single dimension called calendar, and I can connect, give both the relationships to that particular uh, dimension, and I can shift the relationships as per the requirement in my machine. So that's called role-playing dimensions. So let's see how we do that. First, we just take off ship date calendar. That's will be not required anymore. So take that off, delete from model. So after deleting ship date calendar, we have only order date, order calendar. So let's rename order calendar as calendar, because it will be kind of a universal table that will be getting the ship date and the order date. So, and the next thing to do is to connect the ship date key with the date key to build a relationship between those two. And when you build a relationship, you will see that the relationship is inactive now. But that doesn't matter. So let's do the same in reseller sales as well. Brought in here, and ship date key is built a relationship with those two. So I have, even though the relationships are inactive, the relationships exist between the date key and the ship date key, and also the order date key and the date key, and same vice versa in both internet sales and reseller sales. So if you just move back into one of our fact tables, let's say internet sales. Now what we'll need to do is, with the use of DAX, we'll need to with the use of DAX, we'll need to shift the relationship based on the measure that's used. So we'll configure the measure to use a particular relationship at the particular situation. So let's do that. So firstly, I'll take sales. Sales is the sales measure, and from the sales measure, I'll just build a relationship between the inactive relationship, ship date key, and the date key. So after doing that, I'll do the same for the same will be done for order date key as well. So I'll just go in here, and I'll create something called order date. Sorry, ship date. Calculate sales, and after that I would be going to use relationship. In use relationship, firstly I'll mention the key of the fact table, surrogate key, which is the ship date key. Between internet sales, and after that, what I'll be doing is I'll be just linking it with the date key in the calendar. There you go. So you have the measure that's created, the sales measure that's created based on the relationship between shift date key and the date key. So at this stage, only the relationship between shift date key and the date key is active when it comes to the calendar, when it comes to the dimension calendar, and when it comes to the internet sales fact table. So if you want to create a relationship, if you want to create a measure with the relationship between order date key in the fact table and the date key in the calendar table, you can do that by just replacing order date key in here. And you can create a separate measure for that. And so whenever end user needs to analyze based on the order date key, he or she can just, based on the order date key, he or she can just drag in the particular measure and do the analytics with that based on the order date key, and same for the ship date key. So this can be repeated, this can be completed, this can be done in other fact tables in any other way. So that's about it for role-playing dimensions. And I would like to mention that role-playing dimensions are a massive performance enhancement as well. So there is like a huge performance enhancement because you will not be repeating the with the role-playing dimension implemented to calendar here. You will not be repeating uh, the same calendar table. You will not be duplicating the same calendar table multiple times for multiple tasks. You will be just taking in one calendar table, and you will be having multiple relationships with that for maybe the same fact table, and you can basically improve your performance in a massive way. So that's about it for role-playing dimensions. And next, let's move to partitioning. So when it comes to partitioning, the concept is exactly the same as you guys might know when it comes to SQL Server. So it's used to break large tables into multiple segments so that it can be accessed and queried easily, and there will be a massive performance increasement in that as well. So let's see how we do that. So I had already created some partitions when it comes to the resellers. So I go there and show you those partitions. So just right click on the partitions folder under reseller sales fact table, and you can click on partitions after that, and you will be right here. So this is basically the partition manager. So in here you can create multiple partitions for the reseller sales, fact table according to the requirement. So in here I had created two partitions. One partition is to capture the current data only. Current data in the sense data from 2013 first to 2013 31st, December 31st. So when it comes to the data warehouse that I'm using, the latest data is 2013 data. So that's why I had assumed that 2013 is the current year. But when it comes to any other scenarios, you can basically take your current year in and put it into a separate partition. Why so? Why do we have the current data or the data that are related for the existing year in a separate partition? So the reason for that is the current data is usually accessed the most by the end users compared to historical data. Yes, they would access historical data as well for various reasons, but the most commonly accessed in the day-to-day basis is the current data. So it's always important to just partition that separately so that there will be no performance hits or any other issues when it comes to when the end users are looking at the current data. So what I had done is I had just taken the usual Power Query that was existing in the particular fact table, and I had just entered the filter step to filter out the data between 2013 first to 2013 12/31st. So if you go into the sales history, which consists of the historical data, it's the same Power Query. It's just that I had gone to design and I had included a new step here to just partition the data between 2011 first to 2012 12/31st. So that's how it's done. And yeah, so after doing that, you can just click on OK. So you can just create new partitions according to your requirement as well. Just click on new in any table. You can go into the partition. So if I don't have partitions in here, but I guess I'll show you how it happens. You can just click on the partition folder and you will be going to partitions. And you can just partition your data as per the requirement. So in here, in this fact table, I hadn't used partitioning anyway, so it's just a single segment, it's just a single table without partitions. So you can just go into the design view. If I just show you that. Sorry, I should enter my credentials here. Yeah. So if I go into here, I just need to filter based on the order date key or the ship date key as per the requirement and create the particular partition in here. And the step will be added up as I showed you earlier in the Power Query when you include a step here. So that's how it should be done. So that's basically how partition can be implemented when it comes to a semantic model. So next is, I'll just close this for now and I'll go back to my slides. Then next is role-based security. So security measures. So when it comes to role-based security is where you are restricting the number of rows in a particular in your semantic model for specific role, so based on a specific filtering condition. That's what role-based security is. Just for example, just think there are country managers who access. There are country managers who access the semantic model. There are regional managers who access the semantic model. So the country managers only need to see the data, only need to see the records that are in the semantic model that are related to their particular country. So for example, a US country manager only needs to see data that are only related to United States. He or she does not need to see data in any other region or any other country or anything. He or she only needs to focus on the related data for their region. So I'll just go into the demo and I'll show how that can be done. So I have the demo here, and in the demo, I'll go to, sorry, it's not here. I'll go to roles. Roles will be under Tabular Model Explorer, models, and you will see the roles that you had configured. So I had already configured a role called US Manager. So if you just go into the role and say, let's see how I had done that, and US country manager. So US manager, the role, when it comes to row filters, I had filtered based on the dimension sales territory, the field sales territory country, I had filtered it out to United States of America only. So that filters out only that particular data for the specific row. And when it comes to members, I hadn't like configured any members, but you can just go in here and add the members. In other words, in this scenario, you can add your US manager's email address or particular access detail into this, and the security measures will be reflecting in the entire semantic model when a US manager looks at it. So when it comes to tables and columns, so tables and columns in here, we should select what tables or columns that you don't want the US manager to see. So in my situation, based on my scenario, my assumption was that the US manager should see all the tables, all the fact tables and all the dimension tables that are uh, related uh, for United States. But when there can be different situations where you might not want specific rows to see specific fact tables or dimensions. So based on that, you can just click on it, and clicking on it means that this, for example, if I tick on the customer dimension, it means that the customer dimension will not be visible for the US manager in here. So that means that US manager can't see the customer. So that's basically an example of that. So like that, you can just, according to a requirement, you can just restrict access to particular fact tables or dimensions. So that's about it when it comes to configuring a user role, when configuring a role-based security. So I'll just show as an admin. Now I'll connect to, so in here I had already configured the US manager role. So I'll just move back into my semantic, I'll just move into my SSMS and access the, I'll just close it anyway. So I'll just access my, I'll be accessing SQL Server Management Studio here. And as an admin, so I'll show you that. So I have accessed my semantic model with SQL Server Management Studio. And now what I'll do is, as an admin, I'll go and browse my model. It's just getting a bit of time. Yeah, previously it was slow as well. So let's give it a bit of time. Shouldn't take too long.
There is also 11 minutes left of your session.
Understood. Yeah, thank you very much. Yeah, so we have our semantic model here and we can browse it now. So I'm browsing my semantic model as an admin. So I'll just browse for the sales, internet sales. And I would also have my dimension country there. So let's just execute the query. And after execution, you can see as an admin, I can see all the related territory country details, sales details in here. So what I'll do is I'll change my user. I'll click on the top left-hand side of the screen, the icon that's visible on the top left-hand side of the screen for change user. So click on that, and I'll go to roles, and I'll click on roles, and you will see the role. You will see the role that I had created previously called US Manager. So I'll click on US Manager, and OK. And after I click on OK, I will be viewing the data model. I will be viewing the semantic model as, as the US manager role will be viewing it. So we'll be moving into that. As previously, it might get a bit of time, maybe 2 minutes. I hope it will be faster. Let's see how it goes. Yeah. Now I am accessing the semantic model based on the uh, role US manager. So you can see the text on the top of your screen saying that you are browsing the cube using the credentials of the following roles US manager. So that means I'm reviewing the semantic model based on the role US manager. So what I'll do now is I'll just bring in sales territory as a country as I did earlier. And I will be bringing the previous sales figure, previous sales measure, and I'll click on execute. And you can see that now, as based on the with the role US manager, I can only see the sales related to United States of America, not any other country. So that's what role-based security is basically. That concludes my session for the day. So thank you very much for Ben and William for the opportunity given. And I would like to thank Manohar Purna, who had been my mentor for the last 2-3 months. He had been providing me with an immense support in improving this session further and providing a good output to you guys. So thank you very much, Manohar. And also, I would like to thank Google Arilingam, who had been supporting me from starting from the session submissions from the very beginning. He had been really encouraging me to get on with the things. So thank you very much for Google Arilingam as well. So, and thank you for everyone who had attended my session. And I hope you have something to take forward with this. And also, please take some time and provide me with your feedback as well in DataGrillen. So you can access it with the QR code scanner, and you can provide me with your feedback. Any kind of feedback is accepted. I just need to improve myself further and further, and I just want to do a better job to this community in the future. Yeah, thank you very much. And I would like to take in the questions now. Hello. Hello.
We hear you. Are there any questions from the audience? I can see there is one now from Andrew. Do you want me to read it for you?
Yes, sure, please.
So is the old cube type of analysis services no longer used? I'm guessing he's referring to multi-dimensional then, perhaps?
Not multi-dimensional is used actually in the current industry. It's used in several places, but Azure Analysis Services for the moment, it only supports tabular tabular models. They might start supporting multidimensional in the future as well, but as of now, Azure Analysis Services only supports tabular semantic models. So that's why I had I demoed the entire demos, all the demos were based on fabulous on the semantic model type tabular.
Thank you. He also says it was a great presentation, so thank you very much.
Yeah, thank you very much.
There was actually a question earlier in the chat that I actually addressed, but I think it's good if we can actually pick it up for everyone to hear. So there was a question around perspective. So is it similar to views?
I'm sorry, is it similar to?
To views,
views?
like database views, yes.
I would say partially similar, but it's not exactly similar. A view is basically you just get a single table out of a view, right? It's basically tabular. You just get a single table out of a view. But when it comes to perspectives, you can get multiple facts and dimension tables into your semantic model, and you can perform analytics with that. So it's a bit different from views, but partially yes. It's similar in some way, but not fully.